Hello, first thing we're going to do is our POD. Okay, so they want you to evaluate. So when they want you to evaluate, they want you to find f of 3. So normally, remember, it's f of x. So they want you to plug in 3 anywhere that you have an x. Okay, so I want you to find when x is 3. So you can either plug this in your calculator, or if you can do it in your head, that is great also. So I know 3 times 3 is 9, minus 17. I know f of 3 equals negative 8. So now I want you to do the same thing for f of negative 6. Anywhere that you have an x, you're going to plug in negative 6. And again, you could plug this in your calculator, okay, or you can do it in your head. Just remember, if you do it in your head, you need to follow order of operations and take care of your exponent first. Okay, so we know negative 6 squared is 36. So 3 times 36, we get 108. Plus 5, I know my function when evaluated at negative 6 is equal to 113. So now if you can get your notes, okay, we're going to be talking about graphing functions. And there's 3 different families of functions we're going to be talking about. Okay, the first one is linear. So linear functions look like y equals mx plus b, or f of x equals mx plus b. Remember, it is the same thing. Y and f of x are the same. So to look at a linear function, we're going to look at y equals x. Now remember, I just said it should look like y equals mx plus b, where m and b are both numbers. So actually, let's go back. M and b are both numbers. So we want to make sure that we write that down. So looking at my formula here, okay, we know m is what's in front of x. So how many x's do I have here? 1. Okay, and then my b, since b is not there, what number means nothing? Right, we know that is plus 0. So really, y equals x is the same thing as 1x plus 0. So we're going to use y equals x, and we're going to make a table to graph. So I'm just going to pick negative 2, negative 1, 0, 1, and 2. Okay, so if I know x is negative 2, I can plug that in. So y equals negative 2. We can do the same thing for negative 1. If x is negative 1, y is negative 1. Then we can fill out the rest of the chart, and we can plot these points. So at negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 2, 2. Once you have your points, you can connect them with a line, okay, and you want to make sure that you have arrows on the end showing that your graph is continuous. So you could pick any values for x, and they would be on this line. So you want to make sure you keep arrows on the end showing your graph is continuous. So that is what a linear function looks like, which if you notice, your graph is a line. So a linear function, when graphed, looks like a line. Okay, our next one is a quadratic function. Okay, for quadratic functions, we're going to use y equals x squared. So your highest exponent is 2. So remember, your exponent is the little number above your variable. Or we can also have f of x equals x squared. So now we can look at our graph, okay? So using my t-chart or table, I'm going to use negative 2, negative 1, 0, 1, and 2. So I'm going to use my y equals x squared. Okay, and wherever I have an x, I'm going to plug in that value. So I have negative 2 squared. And remember, any number squared is always positive. Negative 2 times negative 2 is 4. If I have negative 1 squared, I have 1. 0 squared is 0. 1 squared, 1. And 2 squared, 4. So I can plot these points. So I'm at negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Now, with quadratic functions, it is very important when we're graphing that we make sure we make a nice U. Okay, we don't want a V, we don't want straight lines, we want a nice curved U. A quadratic function, your graph is called a parabola. So these look like U's. Okay, and what do you notice about both sides of your graph? Does anyone notice anything? If you look, going right down the middle of your graph, it's like you have an imaginary line of symmetry. You could take the left side of your graph and flip it over the right side. It is a reflection. So if you have one side of your graph, you can always get the other. So quadratic functions always look like U's. Okay? So if it was a negative x squared though, then we know our graph would be opening down, but you still want it curved. Okay, our next family function is absolute value. Remember, absolute value are your bars. So y equals the absolute value of x, or f of x equals the absolute value of x. Okay, so we're going to use this to graph. So y equals absolute value of x. And making my nice table again, I'm going to use negative 2, negative 1, 0, 1, and 2. So if we plug in x, the absolute value of negative 2 is 2. The absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2 is 2. So I can plot these points. Okay, and now if you look at your graph, now it looks more like a V. So absolute value functions, your graphs look like a V. So we're going to have nice straight lines connecting my points. And again, your graph could also open down, but you just want to make sure it always looks like a V. So you want to make sure you're writing on your notes what these graphs look like. So far we have a V, we have a U, and a straight line. Okay, so there's 3 different family functions we'll look at. So now we're going to classify. So you have linear, quadratic, and absolute value functions. So we're going to determine which type these 4 are. So my first one, what do you notice right away about your first equation? Right, you have an exponent of 2. What function family has an exponent of 2? Right, that would be quadratic. So this one is quadratic. Okay, if I look at my second one, right away we notice we have an absolute value in there. So that has to be an absolute value function. And if we look at the bottom 2, we have 4x minus 2. Okay, so it resembles mx plus b, so we know this has to be linear. And my last one, again, we notice right away we have a squared, so this has to be quadratic. So again, you're just looking at how to classify your family functions by what's in your equation. So if you have absolute value bar, you know that's absolute value. If you have an exponent of 2, that is quadratic. And if you just have an x, you know that is linear. Okay, so now I want you to do these next 4 at your seat on your own. Okay, so my first one, do I have an exponent of 2? No, so we know it can't be quadratic. Okay, and then we can think of absolute value. Do I have absolute value bars in this first one? No, but does it look like mx plus b? Okay, if you don't have a number here, remember that can be plus 0, so this is linear. My second one, right away, we notice an exponent of 2, so that has to be quadratic. If you look at the third one, these bad boys right here tell you that that is absolute value. And my last one, we do not have an exponent of 2. We do not have absolute value bars, and it does look like mx plus b, where m is 1, so this will be linear. Okay, so we've looked at what the graph should look like. We've now classified. Okay, now they're going to give us a specific domain. Okay, so when you have a specific domain, so they're telling you, remember domain is x, so you're going to evaluate when x is negative 2, negative 1, 0, 1, and 2. Okay, so I want you to take some time, fill this out. So wherever you have an x, you're plugging in negative 2 for the first one. Okay, and then you're going to plug in negative 1. Okay, so I want you to finish filling out this table. Okay, so my first one, negative 2 plus 2, I know is 0. So I know x is negative 2, y is 0. Negative 1 plus 2 is 1, so x was negative 1, y was 1. 0 for x, when I plug it in, I got 2. When I plugged in 1, I got 3. When we plug in 2, we get 4. So now that you have distinct points, and they only want you focusing between negative 2 and 2, okay, we're going to graph this. Okay, so we had, I actually forget the points, negative 2, 0, negative 1, 1, 0, 2, 1, 3, and 2, 4. When they want distinct points in your domain, you're just going to plot the ordered pairs. So when given set domain, only use points. So if it's not specific and you can use any number, so all reals, that's when you have arrows on the end. So this is all we have to do for this graph. And if you notice, if you happen to draw a line through there, this would be a linear function. And remember, it was x, y equals x plus 2, which looks like y equals mx plus b. So again, when you're given this Set domain, you only want the points. So let's look at another one. You're going to graph for all real. So when they say all real, that means you can pick what values you want to use. So how about -2, -1, 0, 1, and 2. So right now I want you to take a second at your seat and plug in those values for x. Okay, remember when you're plugging these in, you want to use your parentheses around your x value. So I want you to find those values at your seat. Okay, so we know -2 squared is 4, -2 is 2. -1 squared is 1 minus 2, which is -1. 0 squared is 0, -2. -2, 1 squared is 1, -2. We get -1. And 2 squared is 4 minus 2, which is 2. So now I can write what my ordered pairs are. -2, 2. -1, -1. 0, -2. 1, -1. And 2, 2. So we can plot these points. So -2, -2. And then we had -1, -1. 0, -2. Whoops. Oh, and actually, sorry, I just put my point at the wrong one. We were at -1, -1. 0, -2. 1, -1, and 2, 2. Okay, remember, when you have an x squared term, your graph should look like a U. So when we draw this, since they said we could have all reals, we're going to connect our points, making sure it is curved and not straight, and put arrows on the end because it could be any number. So they didn't set the value we were using. They told us we could use all real numbers. Okay, so now I want you to do this one. Okay, y equals 8x. We're going to use all reals again. Okay, so you can pick any 5 numbers. Okay, I always like to stick to the basic, -2, -1, 0, 1, and 2, just so I know that it will fit better, usually on your graphs. So I want you to find y for both of those. Okay, my first one, 8 times -2. So we plug in -2, we get -16. When I plug in -1, I get -8. If I plug in 0, anything times 0 is 0. If I plug in 1, 8 times 1 is 8. And if I plug in 2, 8 times 2 is 16. So to graph this, okay, if you notice, since we were multiplying by 8, we were increasing by 8 every time. I'm going to have my graph, I'm going to change it. So instead of counting by ones, we're going to go by 8. So 8, 16, 32, and then I'm just going to scribble out these numbers. Oops, and I actually missed one. It should be 8, 16, 24, and then 32. So then to do my negatives, I know I have negative 8 and negative 16, and then the rest of them don't matter. So my first point was negative 2, negative 16. 1, negative 1, negative 8, 0, 0, 1, 8, and 2, 16. Okay, so if you notice, since we could use all reals, they were not restricting what we could plug in. So we know that we want arrows on the ends of our line. Okay, and since this is a straight line, we know this would be a linear function. Okay, and we are done for today. Okay, so I want you to make sure that you have these notes filled out. Hold on to them for tomorrow, because tomorrow you will have a worksheet going over 3.4. So do not lose these, please. Please work on something else quietly at your seat until the end of the period. Have a great day.